What is this talk going to be about? First of all, if you're in the back, I noticed that the code examples might get a little small, so move to the front if you like, or use binoculars. First of all, I will tell you what Varnish is, why you need it, or why you might need it. I have to give an introduction to HTTP headers. Some of you may know this already, some might not, but Varnish relies heavily on headers and how they work. So then I'll go into the internals. How does Varnish internally work? I'll disclose the Varnish configuration language, how to create your own configurations. I'll cover how we flush content in Varnish. I'll explain some fancy acronyms. And I'll leave you with a couple of practical tips to get started on your own. So first of all, hi, I'm Mattias. I already got the introduction, so let's skip that. First, what is Varnish? Varnish is a lot of things. It is what they call an HTTP accelerator. You put it in front of a website, an application, or an API, and it makes things faster. It's actually an HTTP cache. It will cache responses so you don't have to fetch them from your backend all the time. It's essentially a system daemon, so it's something like an Apache or a MySQL server. It is a service that will run on your Linux machine. And it acts as a reverse proxy, so it sits between your browser and your actual web server. It's also a load balancer, so you can use it to fan out requests over multiple backends. And it uses something called the VCL to create its configs, which is a C-like language and should look familiar for most of you. And it has a concept of vmods, something like binary extensions that you can load that provide extra functionality that you can call as functions in the VCL language. Important to know, there's a couple of Varnish versions out there at the moment. The most common that you'll probably still see is Varnish 3, but that's end of life, so we'll no longer get security updates. Varnish 4 is the current stable release, 4.1 actually. And Varnish 5 is expected to come out somewhere next month. The features, if they are ready, should be that they support HTTP 2 and TLS. Important to know is that those configs that we're about to see, they can't really be transferred between 3, 4, and 5. So there are small differences in either syntax or in the way that they work between those Varnish versions. So keep that in mind if you're upgrading from 3 to 4. Why would you use Varnish? Performance is probably the key area why you're here, because it can cache and speed up an application. But it's actually more of a scalability tool. It helps you scale out an application from 1 to 100 servers or from 1 to 2. It offers you a lot of control, so if you want to interfere with requests, Varnish offers you that ability. And it also offers you a layer of security. By just putting Varnish in front of your current servers, you can easily mitigate current known attacks. The HTTP proxy one is one that came out somewhere like last month or 2 months ago, easily resolvable in Varnish. And just installing Varnish automatically protects you from attacks like slow LoRa's, where you very slowly try to get the server to respond. Now, the introduction to HTTP headers. This only takes like a couple of minutes, so if you already know it, pop up your laptop. For starters, what happens when you request something on the internet? So Varnish requires that you understand the HTTP protocol. If you don't, you're going to have a pretty difficult time actually getting started with Varnish. It's all about HTTP headers. So the request, the response headers, you don't have to know them by heart, obviously, but you have to understand how they work and how they operate. For instance, a request. Someone wants to browse a particular website, it opens their Chrome browser, and they get started. What actually happens? For starters, very low level, the browser is going to start a TCP connection to a particular IP address on a particular port. And once that connection is established, it'll send out HTTP headers. This is in the HTTP 1 version, not to be mistaken with the second version. It's all plain text, so you could actually just telnet to a server, start typing commands, and you're emulating a browser. What does that look like? You start with typing your request. What do you actually want to do? You tell it what kind of verb you want. This could be a post, a put, a patch. You tell it which resource you want to load, in this case the home page, the main resource, and which protocol you're going to be talking. Then you can send additional headers that describe what you accept as a browser. If you're implementing APIs, this could say that you want a JSON response or an XML response. You, the browser, will also say what kind of content encoding you want. So either if it's plain text that you want to have back, if it's gzip, deflate, there are a couple of different algorithms out there. You will tell that IP address that you connected to, because that was really low level. Now you will tell that server that you connected to what virtual host you would like to load. So if you have multiple sites on a single server, this will actually tell you which site you would like to load. You can describe who you are, what user agent you are, so this is easily fakeable because it's just a header, a line in a certain protocol. And if you have cookies set on your browser, you will send all of those cookies back to the server so you can be identified by a session ID. Really simple. It's key value store-like idea. You have a key, you put a value to it. Very simple, new line separated, as long as you don't enter 2 new lines, because that's when the headers end. And if all goes well, the server will send you a response, which basically looks the same. It'll confirm the protocol that it also speaks. It'll tell if it's a 200 or a 301 or a 404, you know those headers. It can and probably will send a cache control header to determine the resource that you're about to get, either a CSS, JavaScript, or something HTML-like. Can I cache it or not? In this case, it will say, no, you cannot. It's a private response, and you can only cache it for 0 seconds, meaning never. It'll confirm what kind of content encoding it shows, so the client accepts encoding said that it supports gzip. In this case, we confirm that the response is gzip. It'll also tell you how long the response is, so that once the browser starts getting that content, it knows when it ends. It may say what kind of content type, for character encodings, etc. And in most cases, it will also tell you what kind of server responded. This is just some fancy header, doesn't really mean much, except in most cases, it shows the entire version string, something that I recommend you disable. And it may put on a date, which is relevant in case you use last modified headers, because the last modified dates will be calculated against this date. So that's HTTP headers. I promised it wouldn't take long. Now, how does Varnish work? It sits between a client, meaning a browser, and your Apache or your Nginx web server. So it acts as a proxy. And in that role of a proxy, it will decide for the request that comes in if it can respond with something from its cache, or if it should fetch it from the Apache or Nginx backend. To do so, it listens to the HTTP headers, both sent by the client and those responded to by the server. The most common ones you'll see are the cache control expire headers. If you're just getting started with implementing Varnish, only look at those because those are the most important ones. And it also has a concept of routines. And routines in Varnish are pretty much what make it really powerful and really complicated. You can plug into routines. You will see in a minute that there's a diagram which is rather complicated for all the different parts where you can plug in your own code to manipulate Varnish. So just to explain the proxy concept, normally your browser or your user will use its browser and connect directly to an Apache web server. If you introduce a proxy, it will connect instead to Varnish, and the user probably doesn't know what is running on the backend. That's the idea, because Varnish will be the one doing the communication to Apache, and your user only sees Varnish. Straightforward. If you ask the Varnish team, what does Varnish look like internally, you'll get a diagram that looks like this. I don't find this very useful. This is rather Chinese to me, and while it's probably 100% accurate, this is not the best way, I think, to explain what Varnish is. So I'm going to take a different approach. Whether it's a good one, we'll see at the end. This is how I like to visualize Varnish. You start by having a user, using its Chrome or its Firefox, connecting to a server where Varnish is running. So it's probably connecting to a service listening on port 80. What that does in Varnish is trigger a routine called VCL receive. This is the first part in Varnish where you can plug in extra code, extra logic for manipulating whatever the client sends in. In the best case scenario, Varnish will look up that request that you're making, look it up in its cache, and if all goes well, it can find a hit and then trigger a different routine called VCL deliver and deliver that back to the client. Everybody happy? This was the most best case scenario that you can have in Varnish, because this was a cache hit. Nothing had to be fetched from the backend. Of course, this is not always how it works. So the alternative is, if it's a cache miss, that Varnish will have to issue the same request from its backend, your Nginx or your Apache, and it will do so by triggering a VCL backend fetch routine. Again, it's something that you can plug into and extend the functionality, but I'll explain that later. What Varnish then does is send out its own HTTP request to your web server. That web server will do its best to come up with a response, give that back to Varnish, which will then trigger a different routine called the VCL backend response. Varnish can and probably will store that in its cache and then hit the same VCL deliver routine to give that to the client. This diagram is something that you'll see referenced again and again throughout the slides. Look at it as this. The left side is everything that the client sees and does, and the right side is everything that the server does, being your PHP code. What does this mean for you, and how can you plug into this? Well, Varnish uses a VCL, the Varnish configuration language, and it's a C-like language where you can write additional logic to manipulate requests. The most obvious or the most common ones that you will see are those receive, the backend response, backend fetch, and the VCL deliver. We'll dive into each and every one of those. What it looks like really on disk is if you log into your server and you've installed Varnish, you will find a file called etc varnish default.vcl. It'll start with a line indicating its version. So once version 5 comes out, that line will most likely change. And then you'll see different subroutines. And within the accolades, you will find your actual code. For instance, this is the actual Varnish code. So this is the code that lives inside a subroutine called VCL receive. And if you remember the diagram, it's the very first step that Varnish will hit the moment your client has sent a request. We can do a lot of things with this. We can write really simple, or simple in our case because we do PHP, C-like syntax, and we have a different set of methods and objects that we can act upon and rely logic on. So we have the request object, and we can discover the method. This could have been a post or a put, a patch, whatever. And in this case, we're going to say that if it's not a get or a head, it's probably a request that has altered the data in some way. We don't want to cache it and just return pass and let Varnish send that to its backend. But we can also use that same place, that same entry point within Varnish to change some of the requests. For instance, if you use Google Analytics on your site, and 90% probably do, you know that Google Analytics will set extra cookies, etc., on each of your pages. All of those cookies get sent to your web server on every page and every asset that you want to load. But maybe your web server doesn't actually need that. So you can use the VCL to strip out those cookies that you don't need. You do so by looking at the request object, and then there's an HTTP object inside of it. That is the raw headers that your client has sent. So you will also find an accept encoding, you will find the host header. All the headers that your browser has sent to Varnish can be changed, modified, deleted, or added here. And then there's a reg sub all, which is a regular expression substitution going on, meaning on this field, we will look for this particular regex and change it by nothing. So everything that matches the __UTM wildcard cookie will be deleted. Things like this give you a lot of ability to do good, but also do evil, because if you mess up here, you're really messing up low-level protocol stuff, and what comes to your backend may be Chinese. At the same level, so the very first entry level of Varnish, where it just got the request from the client, you can also say that if the host header is something like a particular website, you can route traffic to a different backend. So if your Varnish is aware of not only one web server, but 10, and you'd like one Varnish to be responsible for 10 different servers, you can use this method to call upon specific backends. Those backends are just defined a bit higher up in the config. And Varnish can use this as a very dummy way of balancing the load between multiple backend systems. You can also do things like stripping cookies if they are not needed, because most of the JavaScript or CSS files probably don't need cookies in the backend, and they don't need it in the cache, which is something that will come up later. So you can use very simple if statements to match everything within this and remove the cookie header. So everything that your client has sent for static content will just get removed. But at the same time, you can also manipulate not only what the client has sent, but also what your server, your PHP code has generated. For instance, maybe your web server is configured to automatically set cookies for some kind of particular extension. Maybe you don't like that. In Varnish, you have the VCL backend response routine where you can easily manipulate that. You see headers being set on your PHP end, and you can just remove them. So in this case, we will remove the set cookie, something that the backend is setting. Notice how there's a difference here. It's no longer the request object, but the backend request. This is already what came back from the backend. So the backend has received or generated a response. Varnish has gotten that response. And before you give that to your cache and to your user, you can still change some of its parameters. So if you remember the diagram, everything on the right was server related. This is before we are going to put the response that we got back in the cache. So this will make sure that the data that we put in the cache does not have a set cookie header. Another cool one is we probably don't want to cache responses that are not an HTTP 200. So if your client has made a request for, say, your homepage, but the web server said that this isn't working, there's a syntax error, here's an HTTP error, you probably don't want to cache that so that the next visitor gets the same error. You can easily use the same status checks and say that everything that matches a particular status code will never get cached, hence the return abandon. Varnish will abandon the request, will just send the error to your client, but will not cache it. But Varnish can also do very interesting things like enable grace mode. So normally, when your backend has generated a response and it has given it to Varnish, Varnish will look at the cache control headers and decide, okay, you want this resource to be cached for 10 or 15 minutes. It'll put that in the cache with a timer for 15 minutes, and once that timer expires, the content will be gone. But you can also let Varnish say, while the application indicated that it only wants to be kept for 15 minutes, I'd like to keep it for an extra 2 hours, just in case. Because the mantra here is, it's better to serve old content to a user than no content at all. That is what grace mode is, but I'll revisit that later. In the same diagram, if you look back to the left side, so everything revolving the client communication, the last routine that Varnish will hit is called VCL deliver. And in that routine is usually where your cleanup can happen. Cleanup like removing headers that you don't want the client to see. As in the bottom one, you can remove the response that is going to be set. The HTTP stanza is where all of the HTTP headers are kept. And remove the server header. So if you had a web server that was configured to tell you the exact version number, before delivering it to your end user, you can remove that in Varnish. You can also add some if statements that if the object that you're going to be delivering has hits, meaning cache hits, then you can say that it was a hit. If not, it was a miss. And those are just the headers that you can see when you're debugging in your network inspector or with curl. In this case, we'll also remove the x-powered by header, something that PHP likes to set to indicate its own version. But with the entire flow in front of you, it becomes rather difficult to see where change is actually going to be happening, because there are a lot of entry points. I've only shown 4, but there are probably around 20 subroutines in Varnish, each responsible for its own niche thing in Varnish. So visualizing where something changes and how something is going to come out of it might get tricky, because there just are a lot of places where you can change content. What do you put in versus what comes out? How do you visualize that? And if you want to manipulate a request, where do you do so? Do you do it in the receiving end? Do you do it in the backend response? Something in between? So let's look at a concrete example of how Varnish can manipulate a request. So if the previous 15 to 20 minutes were a bit abstract, this will get you back on your feet. Same diagram, but in this case, we'll play a bit of a game. Let's say that the user wants to connect to a particular server and say that it wants to load Laravel.com. The end result will be that it goes through the entire loop and something is going to come out of it. But we will use different routines to modify what the client thinks it is going to be getting. So the client wants a GET request on Laravel.com and it claims to be Chrome, a version of Chrome. What we can do, and this is probably why everyone in the back cannot read this. Let's see if I can zoom. Okay. So remember, everything on the left is what I consider to be client-side code. Everything on the right is server-side code. The very first routine that Varnish is going to hit is called VCL receive. And in that, before Varnish will do a lookup in its cache, before it will even send off the request further on, you can manipulate whatever is coming in. So you can say to Varnish that despite that the user was actually trying to be loading Laravel.com, we will make Varnish think, by just updating the host header, that it's going to be looking for forge.laravel.com. And the user claimed to be Chrome, but we will make Varnish think that the user is now an IE5. So if you look back to your backend, the fetch that is going to be performed because at this point I'm assuming it's going to be a cache miss. So Varnish will set that one off to its backend, but instead of taking the original request, it will send a modified request. It will send a request where the web server is going to look like it's receiving a request for forge.laravel.com, which may or may not exist on that server. If all goes well, the server is going to create a response. In this case, it'll say, OK, I found that host. I'm happy to deliver it to you. I'm also going to give you a Laravel session ID, something that should be unique to each and every one of you. And it will say that it has a no cache policy. So the cache control header is being set to indicate that the response we're going to be giving should and may not be cached. And it'll say that, hey, I'm an Apache server. Now, the VCL backend response is another routine within Varnish where we can take that answer from the backend and change it. We don't want to say to the outside world that it was a 200 response. No, we can update the status. So whichever the server thought it was going to be sending, we can update here and make that 200 into a 123 status code. And even though the server indicated that there should not have been a cache in this case, we will update the backend response TTL, the time to live, to 10 minutes. So we've actually overwritten that which our backend has said should happen within Varnish. And because we don't want the Laravel session cookie to be set, we will remove the set cookie header. Notice how this is case insensitive, pretty much like everything in the HTTP protocol. So what comes out at the end is, AKA, what is your client receiving? It thought it was going to be getting a request for Laravel.com and claiming to be Chrome. At the end of the day, it's going to get an HTTP response with a 123 status code, in which case your browser is probably going to say, really, I don't know what to do with this. It's going to get a cache control of no cache, even though Varnish internally is going to be caching this response for 10 minutes. And it's going to say that it's an Apache. What is missing now is the set cookie header that we removed from the backend response. Except that the user is thinking that it's getting Laravel.com. Instead, it's getting the homepage of forge.laravel.com. So this idea of manipulating the request in every possible way gives you a lot of power. It gives you a means to correct mistakes, to set headers, to redirect users. But if you do this wrong, you're probably going to be getting really mixed up results. Varnish will, for each request that it gets into its service on the VCL receive end, it will do a lookup in the cache. Now, to determine what key is going to be used to look this up, a different Varnish routine is going to be called. It's called VCL hash. What it's going to do is, for the incoming request, it will calculate a hash and use that hash to do a lookup in its table. By default, it will look at 3 different parameters. It'll look at the URL, obviously, but also at the host header that was being sent, and if there were cookies, what kind of cookies were present. Now, if you're using Laravel or PHP in general, you probably know that each of your requests is going to be generating a unique Laravel session ID. So if we keep this in mind, the cookie being part of the hashed value to determine if this is the same request as, say, the next one. But if my session ID is different than your session ID and is different than your session ID, our hash is always going to be different. So in this case, working with cookies and making sure that we have a good baseline for our cookies is going to be really important. But there are a couple of other challenges too. For instance, URLs, something that we might think of as something really basic. In the VCL receive, this is the part where we can really normalize everything that's coming in. We can strip out all of those things that we don't need and make sure that the URLs that we keep are sanitized. In this case, we will use the query sort function within Varnish, give that the URL, overwrite its own version of that. And what this does is all query arguments being set in your URLs are going to be sorted alphabetically. Because to your server, it really doesn't matter if you send it this request or this request. But to Varnish, it does, because the order will change your hash key, and you will get different variations of the same URL. So we sort them. And if we go back to the Google Analytics bit, if you use those campaign parameters, you will probably have sent out emails or tweets or whatever with different UTM sources or UTM mediums. To your backend, they probably don't matter either. So in this case, we will use the same regular expression and remove those sort of unique parameters in Varnish. So it can cache a version without having to have a different version for each of your sources or mediums that you've used. I think the biggest challenge within Varnish is how you deal with cookies. For instance, if you have a PHP application, 9 times out of 10, your session ID will be auto-generated, so each of your users are going to get a different and a unique session ID, which is probably good because you rely on this in your application, but this also means that each of your responses is going to be unique for Varnish. It has a unique hash. A couple of solutions, though they aren't really easy to implement, is called lazy session initialization, where you only initialize a session when you actually need one. So not for every home page or every about page, but every time you open a login page or a password reset page or have something in your shopping basket. Only at those specific times will you set a session ID. There are things like the XSRF tokens, which are going to be more tricky to implement. But they are usually only set on pages with actual forms. But that means that the page with the form cannot be cached. You will have tracking cookies, especially if you have a website with ads or just Google Analytics. Dealing with them, unsetting them, and resetting them at the correct time is going to be important if you want Varnish to be as efficient as possible. How can you do that? If you look back at the VCL receive, so we're actually manipulating the request before even Varnish is going to consider a hash lookup in its cache. We import a vmod, the binary extension bits in Varnish, called cookie, and cookie gives us a really interesting parser. If we do a cookie.parse and we set the cookie header, we can more easily fix what kind of headers we do or do not want. In the earlier example, I had to unset a cookie based on some regular expressions. This is a lot cleaner. So you can just do cookie filter all except these 2 cookies. And whatever the client is sending, that is going to get removed and only these are going to be left. So instead of going for a blacklisting approach in your cookies, you're basically going for a whitelisting approach. Now, if you add a different cookie inside of your application, you will have to update Varnish so that it can allow that new cookie to come through. So it's a bit of more of a mix-up between both configs. And at the end of the day, we will make Varnish think that the cookie that the client has set is actually the one that we manipulated in Varnish. Another challenge is just your host header, because there are probably a lot of domains pointing to your website or your application. But to Varnish, those might all end up being a different variation of your cache because the host header is being used in that VCL hash function. One of the ways that you can do this is by fixing your redirects inside of Varnish. So at the same client-side bit of the code, we can see that if the host header is equal to your domain.tld, then you can do a return for a function called sint. You give it a status code, and you give it a reason. And in this case, the reason is just your target to which you want to redirect. Varnish has a different routine called VCL sint, where it can catch those synthetic responses. The status that we set here is 720, so we'll look at this if statement and set the location header to the reason that we gave that function. We will make the response to your client think that it's a 301, so it's a permanent redirect, and then we will deliver this. To your client, this looks like the server just responded with, hey, I permanently moved, here's my new domain. But this makes sure that Varnish only knows, at the end of the day, the www.domain.tld and no longer the different permutations of that same content. You can also use Varnish to do things like caching your API requests. This might sound weird, especially if you're considering authentication, but you can easily bake this in. So the VCL hash function, which is responsible for determining what is going to be cached or what key am I going to use to look that up, usually takes the URL and the host, but it may or may not include cookies. You can just disable that. If you have an authorization header, for instance, for your access tokens, you can make that a part of your hash by just including the hash data and then any arbitrary header that your client has sent. So if you use custom headers for authentication or just say I want to give an XML versus a JSON response, you can use those headers to make permutations of the same cache. This might be easy if you have clients that have dumb implementations of your API, where they just keep requesting the same response. Varnish can cache those, so you only have to fetch them once from your backend. Part 5, flushing the cache. Because putting things inside of Varnish is all fun, but at one point you're going to want to remove stuff from Varnish, especially once your content updates. There are a couple of ways. I count 3 to be readily available. One is using purge requests, which is a rather old method, but very easy to implement if you're just getting started. We'll explore that later. You can also use something rather new called bans in Varnish. Or you can just restart your Varnish service. If you're debugging something, or if you're on development, or if it's really, really urgent, this is actually a really fast way to clear out your entire cache. Purging. Anyone familiar with curl on the command line? 2 hands, OK. What we can do in Varnish is we can define ACLs, so access control lists, where we can just say, either by hostname or by IP address, which hosts we would like to come in. Note that it's a bit of a strange syntax to give it subnets. The IP is between double quotes, then there's a slash, and then there's your net mask. But inside of the VCL receive part, so where we handle our client requests, we can say that if it is a purge method, so at this point you can already see that you can just put in any kind of arbitrary word. If you would like to make this a la 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 request and let that handle its purges, it's very possible. If the client IP, which is something internally in Varnish where it takes the IP that the connection was made on, if it does not match the purge ACL, then we will just say a same kind of synthetic response by, hey, you're not allowed, go away. If not, then we will hit the purge and remove that page, that's whatever it was, from the cache. If you look at this via a curl example, you're basically calling curl with the purge method. You're giving it an arbitrary header. So with -h, you can just throw anything you like at curl, where you claim to be the host of domain.tld, assuming that's your site. You will connect via HTTP to that IP address, and then we come into the URL stage. So to Varnish, you are actually flushing domain.tld/block/page1. And it's going to be allowed because you're doing a purge request and you're hitting that internal logic. A different way of purging content, which is more powerful, is called bans. There's a couple of ways to call these. These examples are using command line tools, but if you look on packages, there are a lot of packages that allow you to use the same kind of protocol inside of PHP with a very nice abstraction layer. So what are we going to do? We're going to call the Varnish ADM command. We're going to authenticate with a Varnish secret. It's just a random bit of string being generated when you install Varnish. Think of it as a plain text password. And we're going to issue a ban request. And then we can use the same kind of objects that we've been using inside of the Varnish configuration language. So we can say, in this case, we're going to ban everything where the host header matches an optional www.domain.tld. If you wanted to do this with the purge request, you had to send, in this case, 2 different purge requests, one for the domain.tld and one for the www.domain.tld. You can also do this on remote hosts. So if you want to use the Varnish ADM command but have it connect to a different server on a different port, that's also possible. So if you have Varnish and, say, a couple of web servers, they can connect to a running Varnish instance. And it can also use more complicated regular expressions. So if Varnish is caching your CSS or JavaScript, but you updated it, you can issue a command like this where you also match the URLs. Now, banning in Varnish is not the same as actively flushing content. In this case, Varnish is going to do a bit of a different approach. Every time that a new request is coming in, so every time a new client is connecting and requesting something that matches an existing ban, then new content is going to be fetched. So in this case, it's not actually removing cache, it is marking particular objects, in this case HTTP objects, to be excluded in the cache for the next run. And at the moment that Varnish decides that there are no more objects in the cache that match this criteria, it will remove this ban from its system and consider it finished. So it won't, by default, it won't actively look for content to be purging. You can configure this if you like it, though. Now let's get to the acronym part. Varnish has really cool inside technologies that you can use. First, edge site includes. They are a way for Varnish to allow you to cache parts of your page. Now, if someone tells you that, you're probably thinking, how the hell can that work? There's a page, there were HTTP headers for the client, it gets a response, that's just one thing. How will this work? Well, it does so by using an ID that basically comes from something like HTML or PHP, where you can include different parts for a page on your main page. But instead of using the PHP way, where PHP would be including your code, Varnish is going to be including multiple parts of your page. And you can have different cache policies per fragment that you are including. So you have a page where multiple includes are being handled. Each of those can have a different time to live and a different cache policy. This is probably Chinese, so there's a diagram. If this is your typical homepage for your favorite news website, it probably looks a bit like this. You have some kind of personal greeting, you have a navigation bar, the actual content, and then it's riddled with advertisements. But as a business owner, you probably look at this page and think, okay, my navigation, it doesn't change much. I would like to cache that navigation bit for like 2 days. If there's a username logged in, well, I actually have to tell that person the username, so that's a bit that I cannot cache. And then we have some ads that we would like to be cached, and then there's the actual content that may be changed whenever you'd like. To Varnish, that looks like this. Instead of using something like PHP includes, in your source code, in your HTML that you generate in your views, you can use ESI includes with a source parameter. This source is going to map to a different route in your application and can deliver different kinds of content. So in this case, we have partials or whatever your path may be to get the content, to get the navigation, a personal greeting. Varnish will take that output that you created and assemble it into a single page. Really low level in your HTML, it looks like this. So wherever you output your content, you will have ESI include tags, so just like this, with a source and a route. This is essentially what you could normally do with just include tags. You would include your content on that part of the page. But in this case, it's not PHP that will be doing the including, it will be Varnish. And in this example, the partial content bit, I'm going to include that twice just to indicate how the caching inside of Varnish might work. The same kind of routine, but slightly differently structured. So your client is requesting Laravel.com. It hits the VCL receive, where you can normalize the input. Does a cache lookup? It doesn't exist, so it does a backend fetch. And your PHP is going to be hit to generate this response. That PHP code is going to deliver the HTML that I've just shown, so this. And it's going to include a lot of ESI tags. Varnish will get those in its VCL backend response. It will see that the content has ESI tags. That's a bit odd. Maybe it should request those on its own to fill in the blanks. So what Varnish will then do, and the client has no idea that this is happening inside of Varnish, it will see those ESI tags. It has detected 3, but 2 are basically the same. And it will issue a request on its own back to your PHP. So PHP, in this case, has already received 3 different hits, so 3 potentially bootstrapped requests to get the content. And once Varnish has received each of those requests back, it will assemble the HTML, put in that output for those pages wherever it needed, and deliver that back to the client. And each of those requests and responses can, again, be manipulated the way that you did with the first requests. So it'll go through its VCL backend fetch. You can change headers, unset cookies, set a different kind of TTL for your time to live. A really powerful feature. At the same time, it's a rather complicated feature just to get your head around and to debug in a development environment. But the main advantage here is that if you have, for instance, code that is rather heavy to calculate your navigation structure, you can have an ESI include, have Varnish fetch that once, and on every page where you want your navigation to be included, Varnish can handle that for you. So you don't have to store that yourself in Memcached or Redis. Varnish will deal with that. But then there's the point of how long can you cache something? Or better yet, when can you cache something? The best approach is having your application set all the headers that it needs. So don't try to be smart in Varnish, try to be smart inside of your application. At the core of Varnish, it will listen to your HTTP headers. So if you set headers that say, there's a cache control policy on this resource, it's public, you can cache it, and you can cache it for 900 seconds, then Varnish will just interpret that header. You don't even have to do anything, and it will cache that resource for 15 minutes. Alternatively, but this is a really dark path that you will walk into, you can update that for your particular URLs if you'd like. Let's say your application sets a cache control for 15 minutes, but you'd like to overwrite this. You can do so by just setting the time to live to an arbitrary value. But if you have a moderately complicated application, you can probably think of your URL structures. This is not the way to go. You can do it, and it works, but it is much more convenient to handle all of this logic inside of your application. Ideally, Varnish is as dumb as possible, even though you can make it really smart, and if you're interested, you could write your entire application inside of Varnish. It's just not meant to do so. Varnish also has a concept called grace mode. So that TTL that your backend is setting, say I want a resource to be cached for 15 minutes, Varnish can artificially override that. So it can take your 15 minutes, happily put that in the cache with a time to live of 15 minutes, but then you can, and this is something that you would have to do inside of your VCL, in your backend response, you can either overwrite the TTL in case your backend has not set one, or you can extend with a grace period. In this case, a grace period is valuable if you work with a high-traffic website and you have a lot of cache stampedes. So you have a lot of users trying to hit a particular resource, which happens to be flushed from the cache. And instead of sending hundreds of requests to your backend, what Varnish will do for all of those hundreds of clients connecting, it will accept them all, send one to the backend, but at the same time, all of those 100 people are going to be getting a response that is probably a couple of seconds outdated. And when Varnish gets that response back from the server, it will update its cache, and the next request, that can get an up-to-date response. Now, to do so, it needs to hold objects in its cache longer than what you actually wanted it to from your code point of view. And that's where grace comes in. So if you set a backend time to live for 10 minutes, with a grace period of 20 minutes, effectively, those URLs are going to be in your cache for 30 minutes. This is not a big deal. Varnish can evict them if it's running out low on memory, but it's a lifesaver in case your backend goes down, say you're rebooting the server or planned maintenance or whatever. Even though Varnish may not be able to get a fresh copy, it can still serve that old copy, which is called a stale while revalidate policy. It's going to serve stale content while it is revalidating the latest content. And it helps if you have hundreds of clients trying to connect to a resource that is not yet cached or that is outdated in the cache. As a bonus round, there's a couple of CLI tools, and I'm a sysadmin, so I prefer these kind of tools. On debugging, on looking at content, on just looking at the code that you're going to be running. First command that you can run at your command line, so you SSH into your server, you open your terminal, is varnish hist. This looks like the skyline of New York, and if it does, that's good news because you have an active server. It's basically a histogram. It looks at a timeline. Everything on the left is a fast request. Everything on the right is a slow request. So you want all of those vertical lines to be as left as possible. Everything that's a vertical line is a cache hit. Everything that's a hashtag is a cache miss. So you want lots of these graphs and as little as these graphs. Now, they don't really tell you much, but they do tell you at a really quick glance, how is my server performing? Is it looking good, or is it all of those hashtags, meaning it's not getting a single cache hit? You can also run varnish log. Don't do this on a busy server, you will probably drown. But it gives you in real time what the client is sending, so all the request headers for each of your clients, and it will also tell you all of the output for each of those requests. So even on a moderate server with 10 requests per second, this will flush your terminal like crazy. But you can use varnish log with some different parameters where you can filter by source IP, so you can only look at your own requests, or you can filter by particular URLs if you only want to debug those. But it's a really useful tool for debugging to see what goes in, as in what are my client headers versus what goes out. But if you don't like that cryptic output, Varnish also has a tool called Varnish NCSA, nothing CSI related, where it just outputs your logs as if it's an Apache or an Nginx log. So if you're used to this kind of output, it's easier to interpret. Try this tool to see what Varnish is seeing. The getting started bit, and I'm running out of time, so this is thankfully a short topic. Really simple. There's a GitHub profile on that page where there's a lot of boilerplate Varnish code. Think of it as your HTML5 boilerplate, but for Varnish. Take that URL, copy-paste it into your config, and you're 99% sure that it will work. To get started, just install Varnish and run it on your own server, or servers, but run it on a different port. So you probably have your Nginx on port 80, run Varnish on 8080. And then test your website, serve to it, see if and how it works. Once that works, swap out those two services. So your Varnish becomes port 80, and your other web server becomes a random port. So the outside world does not see a difference. Your web server runs on port 80, but internally you've switched two functions. And then you can check your cache hit and miss rates. So Varnish log, Varnish hist, all of those tools. And it really is that simple just to get started. Probably won't work right away. Your cache hit rates are probably going to be slow, but you've installed Varnish and you can get started with just messing with the protocol. Thank you.